Okay, so our project was on the hydrogen fuel cell, which is very new relative to all of the other kind of renewable energies like biomass or hydroelectric, so there isn't so much known about it. So because of this, we tried to put as much information as possible in our presentation. And so the way that we get hydrogen, our electricity from our hydrogen fuel cell is a little bit complicated, so we're going to start with the background and how it's used, because I feel like once you understand how it's used, it'll help you better understand how it works. Okay, so we're going to go next slide. All right, so here's a little bit of history. Can anyone tell me what these two things are? I mean, the words are kind of right there. Yes, so those are hydrogen and oxygen on the first one. Yep. So it was invented in 1839 initially. That was the very first primitive version of the hydrogen fuel cell. And this man, William Grove, found that when they react, they create an electrical current. And then can anyone tell me what that image up there of the Duracell is called? Battery. All right. Yes, so that is a gas voltaic battery. That's what it was called in the beginning. And that kind of reflects how it works.
Could you please send Cassandra Lawson to student services? Okay,
so these are all different types of vehicles. So what are these all? So this is can someone tell me what this is? This is tractor. This is? And this is like a sinker. So these are all vehicles. Can you uncover it? These are all vehicles, and that is the main use of the hydrogen fuel cell.
Pause.
Okay, so this is one of the first prominent uses of the hydrogen fuel cell. This is NASA. So it was used by NASA in the 1970s to power space shuttles, which is really, really cool because it produced so much power. And so because of this, we can see that this is what I'm saying, how you can get to know the technology through its uses. So what is this? This is water. So the shuttle crew actually was able to drink what was produced as a byproduct during their mission. And that really shows you how clean the energy is. All right. Pause. Yes, so now we don't really use it so much for the space shuttles because we don't do so many missions into space. But we do have hydrogen-fueled cars, which are basically, they're most known in terms of what the cell is used for. So what are these car companies? Yes. So these are Toyota, Honda, and Hyundai, and they've all developed some form of car that uses the hydrogen fuel cell to power. And then, so what do these look like? What does this look like? It looks like a gas station. This is actually a hydrogen refueling station. So instead of petroleum gasoline, it uses hydrogen fuel to fuel the cars. And so one important note is that these cars can only use hydrogen fuel, and only cars that have a hydrogen fuel cell can use hydrogen. So that is another issue that will come up with the advantages and disadvantages, but just keep that in mind for now. Okay, so this text box correlates with the image in the middle. And this is kind of how we're implementing hydrogen into this, changing world that we have, how we're using it as a renewable source of energy that's more accessible. So what does this say? California. So California has been subsidizing the building of fueling stations for these hydrogen fuel cars. You'll see in a little bit why it's a little bit more rare because we talk about the advantages and disadvantages. But they've been doing a lot of work to build a lot of hydrogen fuel stations. That's one of the places where it's most emphasized in terms of their priorities as a government. And then these countries, I know this is, that is, and then this might, that's the European Union, so.
Did you play that game? Was it called Logos, or I don't know?
So Japan, Canada, and the European Union all are doing similar things to Canada, where they're subsidizing the building of these hydrogen fuel cell fueling stations. Because if we have cars but we can't fuel them, we can't use the cars. And then this car brand, we said it before, Toyota, it's researching fuel cell production. And then, so I know this isn't a hydrogen fuel cell car, but it's making the Prius. which is like it's making this efficient energy more accessible. So that's just, I know it's not really related to hydrogen fuel cell, but I felt it was relevant to include because we are moving toward clean energy for our cars. And this is doing research for that and fuel cell production to make it more efficient and more accessible. Okay, so now we're going to talk about like the mechanics of how a hydrogen fuel cell works. So if you look on that TV over there, there's a GIF that shows like the whole reaction. So the first step is called a proton exchange membrane. So that means that, protons can pass through unimpeded while electrons are blocked. Protons can pass directly through, you see where it says like catalyst over there, and proton exchange membrane. Because if you remember, hydrogen is just one proton and one electron like bonded together. So when the hydrogen breaks up, the proton goes through the exchange membrane and the electron have to go through the electrical circuit.
So you want to say the protons are coming from what element?
Hydrogen.
So the hydrogen protons go into the system and the electrons go down, and then you have something on the other side of the system, which is
Oxygen.
Oxygen,
Mm-hmm.
Okay.
So that means what can power things? If you look, it goes out where that light bulb lights up. Mm-hmm. So then, as the electrons and protons meet back up after the exchange membrane, it bonds with the oxygen from the air, and that creates the exhaust, which is water. Mm-hmm.
So here's a video, a GIF, showing the process of how the electricity is produced.
So now we're going to talk about how we can use these. We already talked about the first one, which was
vehicles.
Mm-hmm. So transportation. We can also use them for backup electricity grids. And this is because they are grid, because they don't need a grid to be able to run, so they're grid independent. So this means that if there's ever an emergency where an electricity grid doesn't work, it breaks down or something, we can use it for information that's very important, so because they won't run out. So they use them for like hospitals and the military with like areas that like have information that's like you need it. It's critical.
Show these pictures.
Okay, so now we're going to talk about how we get the hydrogen that fuels these. So currently producing hydrogen requires like twice as much energy as producing the other two non-renewable sources that you use for a lot for electricity. Yeah. So now we're going to talk about the different ways that you can get hydrogen. So the first one is natural gas. This is the most common way. It most commonly comes from, and it actually wastes about what percent of the fuel?
30.
Okay. The next way is hydrocarbon reforming. So this is actually look at the price. It's the cheapest way to get it. So again, what type of gas?
Natural gas.
Natural gas is treated with very
High temperatures.
Very high temperature steam, and when it breaks down, it releases hydrogen. And these little gray circular type thingies are a catalyst to help make it go faster and get more hydrogen from it. So another way to do this is through gasification. So gasification is when you take low sulfur
Coal.
and you scrub the coal in what temperatures? And when you do this, it releases hydrogen.
So basically, you're getting
So if you notice, we're getting most of our hydrogen from non-renewable resources because hydrogen isn't found in the earth alone, so you have to extract it from resources that have hydrogen in it. So another way is electrolysis. And electrolysis decomposes, it decomposes water into its two parts, which are,
That's the way we want to do it.
So this is very intensive, but it produces pure hydrogen. So if you look on the TV over there, I'm going to show you, if you see there how it has two. So all of these different technologies are right now acceptable to produce the amount of hydrogen that we need right now for manufacturing. But if we were to start pushing to get start using hydrogen fuel cells for like transportation and for electricity, if we're going to push to use that more, then it's not really efficient enough to produce as much hydrogen as we would need.
So as Maddie and Sarah have already touched upon, some advantages for hydrogen fuel cell are, first of all, it powers spacecrafts. Okay, so because we can produce a lot of energy, and we'll talk about efficiency later, it's very efficient and can produce a lot of heat and energy, so therefore it can power spacecrafts. It can also power cars. And lastly, it is
accessible
and
clean.
So it's accessible and clean. That's because that, like Sarah already said, it's clean enough to be able to, when we use certain methods, we can make it pure enough to be able to drink out of. So that's why it's accessible and clean. And the final product doesn't have any fossil fuels, any toxins in it. So that's why it's accessible and clean.
Can you elaborate a little bit on clean, meaning it doesn't produce
fossil fuels or greenhouse gases, the final product.
Okay.
Because I'll get into the disadvantages. We'll see.
Yeah.
We'll see here. So let me start off with that one. Here, this one says it can lead to climate change. Not the actual final product, but when the process to make it, like how Maddie said, we need to use certain, like coal that does emit greenhouse gases to be able to make the product, because we need to get the hydrogen from it. So that process does emit greenhouse gases and fossil fuels, such as coal.
Take into consideration that every problem associated with the mining and production of coal is going to be linked to hydrogen fuel cell, because we're getting most of our hydrogen from there.
Yeah, so since we're getting it from there, like the actual process of it does emit toxins and greenhouse gases, which can lead to climate change, but the actual final product doesn't. So this picture right here requires high levels of energy to produce. So like I said, the actual process of it requires a lot of energy, because you're scrubbing you have to get the hydrogen from another source to get the final product. It's high cost. So that, like I said, the actual process is expensive, and to get the hydrogen is expensive. And so to actually, I think it was Maddie that was saying that we already have some hydrogen gas stations. So these are only in place, they're starting to put them in place in California, for example, and different places around the world. But the gasoline, we don't have already an infrastructure set for hydrogen to fuel cars. So we'd have to change cars, make cars, the engine be able to take hydrogen fuel cell, the power to fuel a car. So not all cars can take this form of energy to power the car. So we'd have to change all that, and obviously implement more gas stations, so that would be expensive.
Hydrogen fuel stations.
Stations, yeah. And then, so this one here, storage issues. So hydrogen is very hard to transport because it's heavy, and the storage containments that it's in is very heavy and would also lead to high costs to transport. It's highly flammable, so hydrogen, it's very highly flammable. Yeah.
Okay, so how efficient are hydrogen fuel cells? So basically, when you're looking at efficiency, you're looking at directly converts chemical energy to electrical energy, and then I want you guys to add to mechanical work, because since we're talking about hydrogen fuel cells, what are we using for cars? So hydrogen-powered fuel cells are not only pollution-free, but they can also have 2 to 3 times the efficiency of traditional combustion technologies, because again, they don't emit fossil fuels and they don't emit greenhouse gases, exactly like Valentina said.
Basically implementing not just energy efficiency, but eco-efficiency.
Okay, so gasoline is in a conventional car is less than 20% efficient in using energy. It is the lowest efficiency because like it starts off as 80% efficiency, then by the time it goes through like the converter and the exhaust engine, it only becomes less than 20%. So the next one is hydrogen fuel cell cars are actually 40 to 60.
In the video.
Okay, hydrogen fuel cell cars are 40 to 60